Okay, I think we're going to go ahead and get started. Thank you all so much for joining us this afternoon. This is SCAG's Toolbox Tuesday program, our monthly free professional development webinar series. And the topic of this month's Toolbox Tuesday is analyzing neighborhood conditions using the R statistical programming language, which is presented by Echo Zhang, who will provide an overview and the demo in just a second. But before we do that, I will be going over some brief housekeeping. So just some reminders before we get started. This meeting length is 1.5 hours, so we'll be done at 2:30 this afternoon. And this meeting is being recorded so that it can be, a recording of this meeting can be posted on our website later for anyone who registered but was not available to join. During the meeting, all participant lines will be muted, but if you have a question, please post it in the chat, and we will get to it during the Q&A session at the end of this meeting today. If you have a question as we're going through the demo, if you need something repeated or anything like that, please type in the chat box or press the raise hand function. And so we will keep track of all the questions and have the Q&A session at the end. And finally, a recording of this webinar and the PowerPoint slides will be available on the SCAG website, and we'll send a link out to everyone who is registered after the event to let you know when they have been posted. And please stick around until the end of this meeting as we have a short participant survey that really helps make sure that we're doing a good job and we're presenting the topics that is of interest to our local jurisdictions in the SCAG region. And as a final reminder, this series is available for APA, AICP, CM credits that you can log after the conclusion of this session. So I will go ahead and hand it over to my coworker, Echo. Thank you.
There you go. Hi, everyone. I'm Echo Zhang. I am within the Demographics and Growth Vision Business Unit here at SCAG. So before SCAG, I was a postdoctoral researcher at UC Irvine. So I've used R to do many different types of statistical analysis that are related to topics of housing, land use, and regional planning for both academic research and for projects undertaken at SCAG. Today, I am thrilled to have this opportunity to share some of the tips and tricks that I use in R. So the goals for today involves two objectives. We will extract, process, and map neighborhood level, or typically it's census tract level characteristics within the city. So the end product will look like something will look like the map on this screen, which shows the tract level variation in median household income within the city of Santa Ana in Orange County. So this is a screenshot version, but in R, you can actually create a pretty neat interactive map, which where you can zoom in and out and look for greater location context. You also have the option to export this map, export the data into shapefile to do more in-depth spatial analysis in GIS. The other objective is to create a local profile for a city. By that, I mean to extract multiple variables that you are interested in learning about the city. So you can put together a nice table that includes several facts related to demographics and socioeconomics for your city. So here is pretty much all you need today, and all the materials are already posted online. I want to point out that the code for you to use in RStudio is supposed to be a .r file. However, we encounter some technical difficulties to upload the file as a .r file, so it becomes a text file, which is also doable, and I'll show you how. But Amanda just dropped in the chat a link to all these materials. And if you have not already, please download all of them. And that will also include the .r file, which you can directly open in RStudio and run the code. Also listed a couple more general resources. So after this session, if you're interested in learning more about the ACS data or the tidy census package, which we will be using today to extract census data, feel free to check these resources out. So before we dive into R, let's take a couple minutes to go through some census data 101. First and foremost, where do you get the data? Many of you probably have already heard of and used the American Community Survey. It's the most commonly used data source for demographics, employment, and socioeconomic characteristics. So the survey is mailed to roughly 3.5 million households every year to facilitate annual update of the data set. So the 1 year ACS covered geographies of with population that's at least 65,000. This includes a lot of counties in California, but not every county. And the 1 year ACS provides the most current data because it covers the past 12 months of data. However, so based on this population threshold, you can see that if you are interested in looking into city level data or neighborhood level data, such as at the census tract or block group level, you won't be able to get it from 1 year ACS. And alternatively, you will need to use data from the 5 year ACS, which covers data for the past 60-month or 5-year period. It's a moving average, and it provides data for geographies that are down to the census tract and block group level. So if you just begin to navigate your way around census data, here's the first take-home message. Use 1 year ACS when the most current data is needed, and of course, when the geography is available. And you use 5 year ACS when you are looking into geographies that are not available in the 1 year estimate, such as cities, counties, and census tract. And of course, the trade-off will be the currency of the data. So it will be less current, but for lower geography, for this higher level of geographic precision, that's the trade-off you need to make. And as to what variables exist in the ACS, the Census Bureau published Excel files called data shells and table shells and table lists through census.gov. We will actually look into that together, and I also provide the table shells and table list file for the most current ACS in our training materials. Okay, another thing I want to talk about is census geographic hierarchy. So on this graph, you can see the highest geographic level from the nation to smaller geographic units that all the way down to the census block. If you can see a line linking two geographic units, that means the lower geographic units nest within the higher level geographic units. For example, I circled there, you can see a link between counties and census tracts. So census tracts nest within counties, meaning that census tracts do not cross county boundary. On the side, you can also see under states, there are geographic units called places. This is the census term for local jurisdictions, including cities and unincorporated areas. So places or local jurisdictions do not nest within counties, and census tracts do not nest within places because you don't really see the line linking these different geographies together. So this, when it comes to statistical analysis, like analyzing neighborhood condition within the city, it's a little tricky because you can't really directly extract the census tract within a city, at least not from the census data like ACS. And you will need an extra step to look at a file, a crosswalk file, which essentially gives you provide a list of census tracts that are within each city. So I also provide this material, this data file in the training material, and we will look at that together. So all the analytic steps are outlined in this .r file called Toolbox Tuesday July 2024.r. Let's see, the rest of this page, we will come back and do a recap, but now let's just head over to our studio. And I'm going to share my screen. Hey. All right, so you should be looking at my screen right now. So as you can see, I have a Toolbox Tuesday folder created, and for now it's placed on my desktop. So within my Toolbox Tuesday folder, I have these materials uploaded. You should be able to download all these Excel files and a .r file called this Toolbox Tuesday.r file. So if this is the first time you use RStudio, you might want to do right click and just choose to open it in RStudio. Otherwise, if you have done it before, feel free to just click and have it open in RStudio. And I also don't have the latest version, so I'll worry about that later. But hopefully you have the up-to-date version and it will work. So here we are at RStudio. Right away, you will see like 4 different quadrants here. These are different panes within RStudio. So if you don't see it, you can go to View and Panes and just click or check Show All Panes. Then you should be seeing all of these. So, and the order on your screen might look a little different, but basically you have this console screen where you can directly type in a line of code and have it run. So let's just go ahead and start typing a line of code here. So one classic example is just to have your software return hello world to you, and you can just say type print and click enter. Automatically the parentheses will show up, and then within the parentheses you will type hello world or something else you want R to say to you in quotation mark, and you're done. When you're done, just hit enter. There. So you run this line of code and R give you the result saying hello world to you and to the world. And of course, for something that's more complex, you will build a script, which you are looking at here. So this is the script window. And on the right-hand side, for some of the interface, it might be the left-hand side actually. But for me, it's on my right-hand side. You have these 2 different panes, and we will talk about it as we go through the script today. So now let's look at our script. Oh, other thing. So this is the script you directly open from. You get the script when you directly open your .r file. But say if you don't have R installed yet and the file you download show up as txt, like the one that you are seeing on the online posting. So what you can do is to click here, say click new file, and then R script. It's like opening a new Word document in Microsoft. And you just need to copy and paste the entire txt file here, and you will get a script that look like this. You can also open the script from clicking file here and open file and navigate to your local folder. Okay, not gonna do that. So now let's look at the script together. You can see that the first almost 30 lines, each line start with the pound sign. This is telling R that these are text comments, so it's not executing any functions here. Usually you do it for documentation purpose. So here I have a brief introduction, kind of like a brief overview for this R script. And here I have a block of text that's detailing the analytic workflow we are going to practice today. So as I mentioned, we are going to extract, process, and map tract level characteristics within a city. So the example we are going to use is median household income within the city of Santa Ana. So we're gonna try to reproduce the map you just saw. To create that map, let's mentally map that process in our head first. Well, you will first need tract level data such as median household income from the census. And you will also need to know what census tracts are within the city of Santa Ana. And once you have these two files, the tracts and tract data, you can join these two files together and get your tract level data for the city. From there, you can create your map. So that's the basic first task we're going to do. And it actually involves a good number of data wrangling skills in this process. And after we go through that, we will look at another example, where we will extract multiple variables to create this local profile for a city of your interest. All right. Now let's get our setup. Here to get started, you will need to install the packages that you're going to use for today's data analysis. So this is like downloading and installing software. You only need to do it once. I already done it, that's why it's commented out for me. But if you haven't done it, go ahead and uncomment these lines. There's a keyboard shortcut to do it, but so that you can see it, I'll just delete the pound sign here. So once you can see that once you delete the pound sign, the color of the text change and it's no longer just text comment, it actually become a line of codes where you will run and ask R to execute. So to run a line of codes, you will put your cursor here or highlight this line of code and then just click run, and then R will start doing it. For example, so now the console will give you instant feedback, and you can see that it's installing this packages called Tidy Census. I already install it, but it's okay. You can run it again. There is also keyboard shortcut to run a line of code. It's I have it in the slides, but today for the demo, I'm just gonna use my mouse to click run so everyone can see. So if you have Tidy Census successfully installed, go ahead and install these other packages, so Tidyverse, it's a set of packages that have very neat functions for you to process and manipulate data, and then map view and SF packages are the ones that allow you to do mapping and spatial analysis in R. And I also want to point out that if you are a new user or non-frequent user in R, you might have troubles installing these packages. I hope all of you can have the packages installed, but if you do run into issue installing any package, that's okay. That will stop you from probably following part of the code here. But for that, to address those questions, I usually need to look into the error message. So I'm happy to circle back after the session to help to guide you through it. But for now, let's try to install the packages. the ones that you can. And here I also outlined some common solutions, and I can circle back to talk about it if a lot of you have issues getting the packages installed. So I'm gonna comment these back. And now, so once you install the packages, you need to load them. This is something that you have to do every time you start your analysis. So it's like if you install Microsoft Word, every time you use Word, you will have to open the app. So in R, you will need to load these packages. The function to load the package, it's called library. And then within this parentheses, you just type the name of your package. So let's go ahead and load these packages. This time I'm just gonna highlight a chunk of them and hit run. So if you look at the console, you can see that R is doing something here. It's loading these packages for me. All right. So when R is done running your code, you will see a little angle bracket here. That means it's done. Also, you won't see a little red dots here, which give you a stop sign. So if you want R to pause, you can hit that little red stop sign there. Okay, so after installing and loading the packages, one more thing to do in the setup is to direct R to tell R which working directory you are R will be getting the data and storing the output. It's always good to just first check your working directory. I like to do that because it will also make it easier when I set it up. So to see your working directory, just type get wd, I think short for working directory, and parentheses. That does not need to include everything. So go ahead and run this. In the console, you can see that my working directory is in this Toolbox Tuesday 2024 folder on my desktop. So that's the little folder I showed you just now. So when you download all the materials, put it in a folder and put in the folder where you want to work within. And next, you will set your working directory to that folder. So this is the folder that I want to work within because all my data are there. So to do that, you just write set working directory, and then within the parentheses, you will put your file path in quotation marks. So the helpful thing to do get working directory is that I know because I sometimes use Mac, sometimes use Windows, and I realized that sometimes the backslashes or forward slashes actually make a difference in your R environment. So the get working directory kind of provide you with some idea that the kinds of format you need to input for your file path. Here I do another step to create a output folder under this Toolbox Tuesday folder. So it's dir.create, directory create. This is because I plan to export all my outputs into one single output folder instead of being put together with all my raw data materials. Of course, you don't have to do this in R. You can also just right-click in your folder and do output. So this is the output folder. All right. Even if you have done it, you can still run it. It will give you a warning message saying that it exists, but that's okay. And there's an optional step you can do for your setup, which is to get and activate your Census API key. I believe Census API key is covered in greater detail in part 1 of this Toolbox Tuesday series on census data and R. So it's a tool that allows you to interact with census data programmatically. What you need to do is to visit this website and request the key and then activate the key from the link that you received in your email. So once you get your key, this is my key, but once you get your key, you can just replace my key here with yours and run this line. So in practice, if you don't have a census key, R will give you like a little message saying you don't have a census key. And I think it also limits the number of data extraction you can do in R. But for today's demo, it doesn't really impact it. So this is optional. Okay, so we're done with all the setup. Hopefully it goes well so far. And we will begin this analytic workflow I just mentioned up top. The first thing to do is to read in a local CSV file. This is the crosswalk file I'm talking about. It's the one that gives you all this that gives you the census tract for each city. So I provide a version for all the local jurisdictions within the SCAG region. But later I realized there are out of the region participants, so I also added a national file there. This will be updated later in the post-session recap email. But let's go ahead and look at this place to track crosswalk file for SCAG region. Let's expand this so we can see it better. Okay, so here each line it's a census tract. So for example, you can see that for the city of Adelanto, you have approximately eight census tract. So here, for example, for tract 91.33, you will have two data fields here. One is called POP20 and one is an allocation factor. What this means is that for this 91.33 census tract, there are about 7,500 people. There are 7,500 people of 7,500 of the tract population that's within the city, and that accounts for almost 20% of the city population. So that's a pretty major census tract in the city. In contrast, in this tract, 91.34, only 27 of the tract population is within the city of Adelanto, and that accounts for less than 0.1% of the city population. So usually, remember I said that census tracts do not nest within cities. So usually in this case, when you have like a very small allocation factor, it means that the census tract probably only cover a small portion of the city along the city boundary. So when it comes to mapping, you may want to exclude this census tract, otherwise your city boundary is gonna look funny. So there's that. Another thing I want to point out is that the raw data that you get, this crosswalk file for it has two header rows. Ideally, we just want one header row so that we can do our normal data manipulation process. And I'll show you how to read it in properly in R. Okay, don't save. Now back to R. Let's start with this portion. So read underscore CSV is the function you will use to read in this CSV file, pretty straightforward name. And if your data file is stored directly within your working directory, you can just put the full name of your file in quotation marks within the parentheses. So normally this will be enough, like that. But the extra step here is because we have two header rows in that spreadsheet. So we want to just skip the first row. So we only get one header row for this when we read in this local CSV file. And here on the left side, we see a little left pointing angle bracket and a dash sign. So it looks like an arrow pointing to the left. What it means is that you are telling R to execute this read CSV function, and then for the output you will store that output in this item or data frame called crosswalk. So let's run it and see what you get. So here we run it, and then you should be able to see. So here, find your environment tab in one of the panes, either on your left-hand side or right-hand side, and you will see that this crosswalk data frame that you just created show up in your environment. So you can just click it, and here within your environment, here you will see the entire spreadsheet is read into R, and it's just like, other than having one header row, it's just like what we looked at just now. So you have these 8 tracks for the city of Atalanta and other jurisdictions in the SCAC region. It also standardized the track ID format. So in census data, the track ID is supposed to be 6-digit, and sometimes it's in the format like that. So you have 4-digit and then a dot and then 2 more digits at the end. We'll put this here for now and we will come back to it. So now the next step is to get your data from ACS. The example we're going to do in this first exercise is median household income, and we are going to get data at the tract level, as I mentioned. And for tract level, we need 5-year ACS, and the most recent version is 2022. The 2023 5 years ACS data will be released in December this year. The function to get ACS data is simply get_ACS. Sometimes if you want to learn more about the package of the function in R, you can type a little question mark and then followed by this function name. So you run it in your, so it will automatically switch to your help tab, which gives you some pretty detailed information for this function and regarding what types of arguments that it allows and the detailed explanations for each argument. And then I think all the way to the end, you will have some examples telling you how to do it. So get ACS does allow a good number of arguments. That's because you need to tell R, you need to give R the parameters and tell R what variable, what data, at what geographic scale, from what survey data you want to extract it. And this example provides some the common ones we use. So it's a similar structure in terms of syntax. You will ask R to run this get ACS function, and then your output will be stored in a data frame called ACS data. And like I said, for get_ACS, you have more arguments here, and you don't really have to do this 1 line per argument format. I like to do it because I think it's for better visibility. But if you delete it, it doesn't really make a difference if that's your preference. So the space between arguments does not really matter. Okay, so the argument here, my input look like this. Geography is track because I want to extract track level data. Variable, this is the code for median household income in the ACS data. For now, let's just go with it, but later we will look into several ways to find regarding how to find your variables from the ACS data. And state is California. County, city of Santa Ana, it's within Orange County. So well, actually not for city of the city of Santa Ana that we're gonna do later is within Orange County. So to limit the number of tracts that I'm extracting, I'll just put Orange County here. And the most recent data is 2022. And again, it needs to come from the 5-year ACS. So it's ACS 5. It also gives you the option to do geometry equals true. So when you do geometry equals true, that means you can use the output for mapping later, which we'll actually do in a second. But let's run this block of code first. Again, look at the console. It's showing that R extracted the ACS data. So check your environment. ACS data is here. So let's take a look. So again, you can see that each row is a census tract. The variable name, it's not straightforward here, but it's median household income. And estimates, the variable estimates give you the numeric value for median household income for this particular census tract. And you also have MOE, which is margin of error, because this is survey data, so it's not precise. And you have the last column as geometry. So it kind of look like a shapefile if you have experience in GIS. So that will facilitate mapping in R in just a second. Another thing to look at is the GeoID. This is a very standard format of tract ID. So it's all these are tracts within Orange County per our parameter just now. So for Orange County, it's the code is 06059, and the last 6 digits is the tract ID we just looked at. So this time it's just 6 digits, it has no dot. And why are we talking about the format of the ID here? It's because we will need to have 2 files with the same ID, so that will facilitate joining these 2 files together later. So just make a mental note here. It's county code plus a 6-digit tract code for GeoID in the census data. All right, let's go back to the code. So we already extract the ACS median household income from 5-year ACS at the tract level for Orange County, and we can immediately just map it. The function to map is called map view, and this is telling R that you will perform mapping within this ACS data frame, and the value to be mapped is under the variable called estimate. Recall that estimate is the one that gives you the numeric value of median household income. So let's run it. Okay, so I hope you can see that on your viewer tab in one of your pane, you will see a county map show up with which is pretty nicely formatted. So let's just zoom it all the way out. Take a look at this. It's an interactive map, like I said. You can zoom in, zoom out, and if you hover around, you can see the values of this median household income for this tract. This is a very high income tract around Mission Viejo area. You also have the option, so here you can change your base map. I do like the grayscale, but if you want richer location context, you can change it to OpenStreetMap. And again, zoom in, you can see where are these high income tracts are located, and also where these lower income tracts are concentrated. So here is the city of Santa Ana. If you can see that little gray-ish sign in the background. So when your geographies are nested, like census tract that's within county, you can directly pull the data and create a map like this. But because tracts do not nest within city, you have to go through an extra step to extract tract within the city. And what we want to do today is to create a map like this, but not for the county, but for the city of Santa Ana. So let's close it. And now what we want to do is to extract the tract within the city. What we want to do is let's look at our crosswalk file again. You can see that there's place name here that gives you the name of the city. Oh, one more thing is you see the little search bar here. You can actually search for stuff, search for information. Santa Ana, for example, then it's like using the filter function in Excel. Then you get a list of tracts that are within the city of Santa Ana. So we want to filter for tracts that have the place name called Santa Ana City, comma CA. And the other thing we want to do is to create a GeoID that looks like what we see in this ACS data because we want to join these two data sets. And what we can do, and recall that the GeoID starts with the 5-digit county code and then a 6-digit tract code without the little dot in the middle. So what we can do is to extract the first component, first 4 digits of the tract, and then the last 2 digits of the tract, and then you can just concatenate all these components together. Let's try this. So my preference to do data wrangling in R is to use the functions within the tidyverse package. If you are an R user but don't really use the tidyverse package, but just give it a shot here. I think it's pretty convenient. So it looks like it will use a pipe operator that looks like this. Percentage sign, angle bracket, percentage sign. There's a keyboard shortcut to type this little pipe operator. So it used a pipe operator to chain all these different actions together. Like we just talked about, we need to filter for tracts within city of Santa Ana. We need to create a new variable called GeoID, and we want to go through some extra steps such as renaming some variable to make it more intuitive, and probably only keep the variables that we wanna keep for to just simplify the process. So the key functions that I most commonly use are filter, mutate, rename, select. Pretty straightforward names other than mutate. Mutate meaning creating new variables. And how it looks is that first, so here the first line is telling R that you are going to do something to this crosswalk file, and you are going to store the output into this new data frame called city tract, because this time we'll actually have tract just for this designated city. And for the pipe operator, when you read the lines, you can think of it as next step. So the next step is to filter for tracts that has the place name equal Santa Ana City, California. The little detail here is that you see I have backticks for place name. Normally, you don't have to do that, but place name, because it has space in the variable name, so to tell R this is a variable, you usually use backticks. Here, I put it in the notes. You use backticks to enclose variable names that would otherwise be invalid due to containing special characters or spaces. And to specify values, you use double equal sign. Later, when you create value, you will just use one equal sign. Okay, so start from filter. Within filter, we're gonna filter for place name that's equal to Santa Ana City, California, in quotation marks. We did an extra step here to limit the allocation factor greater than 0.01. So this is just to add one more condition saying that the tract needs to contain at least 1% of the city population. Remember the example we saw for Adelanto City, you have tracts that are just touching the boundary of the city. So for mapping purpose, if you include that tracts, it will make your city boundary look weird. So we add this condition within filter, and then, also you can put, when you have a pound, you can add this comment anywhere in your script. So once you type a pound sign, everything that follow the pound sign does not really matter. So it won't really mess up your code. So here we have the pipe operator, meaning next step, we are going to create new variables using the mutate function. Here within the mutate, remember we need to separate the track ID, this track ID, get the first 4 digits and the last 2 digits. The function to do it, so it's function within the function. The function to do it is to use this substring. So you're gonna do substring track, the variable called track, which is here, this track variable, and then you will start from the first place and end in the 4th place. So track 1 will give you the first component you need, which is the first 4 digits. Similarly, you will do the second component, track 2, and you will substring track from the 6th place and ends in the 7th place. So the 5th place is the dot, you're gonna skip it. And lastly, once you have track 1 and track 2 created, you wanna concatenate these different components to create a GeoID. So it's the county, 5-digit county code, and then the first component, first 4 digits of your tract, and then the last 2 digits of your tract. And the function to do this the function to concatenate these different components, it's called paste 0 in R. So when you do functions within functions, one thing to make sure is that your parentheses, brackets are symmetrical. This is similar to doing formula in Excel, just to make sure that you have the right number of brackets on this one side. And R actually give you a little hint because you can see as I put my cursor here, this little, the corresponding brackets will be grayed out. So now we are done with creating the variable using mutate. And then the next step is pretty simple. I just use rename I want to rename place name into city. The syntax is rename, new name equals old name, because place name is not really straightforward. And next step and final step is just to keep the variables that we will need to streamline this analytic process. So all we need is the city and then also the tract within the city. So I select city GeoID. These are the 2 variables that I created. Well, one is renamed, one is created. So let's run this full block of code. This might be one of the most complex portion here. Just give it some time to sink in. Okay, it's done right away. Let's see. Okay, let's see. Now we have city tracts show up in our environment. If I click it, you will see a very clean data set that gives you a list of census tracts with the right formatted GeoID for the city of Santa Ana. What you need to do next is just to join the city tracts with the tract level data here. One line of code, the function to join. Today I use left join, meaning that when you do the joining, you are going to keep all the observations on the left-hand side, in this case, city tract, because I want all the tracts in the city of Santa Ana, and the tracts that are outside the city of Santa Ana, I'm just going to exclude it for this analysis. So left join function, within the function, your arguments are data set A, data set B, and by equals this joining field. In this case, it will be GeoID because we have this GeoID created just to match the ACS data. And we will, we are telling R to store the result here in city data. So run, and boom, city data over here. So now this is a data set with only 51 entries, meaning 51 census tracts in the city of Santa Ana. Each row is a census tract, and we have this numeric value for median household income, and then also a margin of error, which we won't really cover today, but in practice, it's important to know that your survey data is not precise, so always consider margin of error. One more step I do here before the mapping is to rename. So this looks familiar, right? You're going to rename after this pipe operator, you will rename, and then rename, you type in the preferred new variable name. In this case, I want it to be more straightforward, so I just call it median household income. I also have to put it in backticks because there is space in it. So instead of this variable called estimate, I will rename it into median household income. One extra step here is just, so ST underscore as SF parentheses, that just to tell R, again, this is to convert the data into an SF object, which is a type of object that contains spatial aspect. So this is to tell R that this is like a spatial file, so you will be able to map it. So let's run it. Also here, I did not put it in store in a new data. You can see city data goes to city data to the left. That just means I'm going to overwrite the original city data here. So I just run it, and we will look. So you see, it's very little change. Estimates become median household income now. And we can use our map view function to create a map for median household income within the city of Santa Ana. Let's run it. Okay, something similar pop up, right? It's a map. Let's zoom out again and take a look. So this is the city of Santa Ana, and I think it pretty much looks like the city boundary, as I can recall. And you will see that lower income tracts are concentrated in this portion of the city, and you have some pretty outlying high income tracts, one here and one here. And if you are familiar with the city, like say if you are a planner in the city of Santa Ana, I think this map alone will give you a lot of insight. And again, you can change your base map into something else to give you a better location context for your map. You can export this map and save it as an image. So I think that's something you can directly just put it into a report. And that's the reason I want to change it to median household income here instead of using estimates, because you pretty much have the correct legend for your map. So say you want to do something that's more complicated, more complicated or merge this city track file with other spatial files in GIS, you have the option to export this data as oh, actually, I skipped these 2 lines, but this is just remapping the county line. So I'm gonna skip it and directly get to line 122. So here you will use the st_right function to create city data, to create a shapefile or other types of spatial data. The very commonly used one are .shp files, which is shapefile. So what you need to do is just put the name of your data frame here, and here you will specify the path and the file name. So remember, we created a output subfolder in our working directory, and we will put this shapefile. We create a shapefile called citydata.shp within this output file. And this extra argument is just saying that if there's already a file there, override it or delete it. So let's click and run. It gives you a warning message in red, which looks a little scary, but that's okay. As long as it doesn't say error, then you're good. So let's go back to our folder and take a look. You can see that when I was working on this demo, I exported a bunch of stuff, but this is what was exported just now, the city data, this whole set of shape files. And if you have GIS on your computer, you can directly open this SHP file in GIS and do additional spatial analysis there. Okay. We actually get through our first exercise by the 2 o'clock mark. So that's great. So we created our map for the city of Santa Ana. The next exercise will be to extract multiple variables for a city to create a local profile. I think I can pause here to see if there's any burning questions before I move on. Okay, no burning questions. Great. Hopefully that's a good sign.
Echo, we actually have one hand raised from Taylor.
Okay. Actually, it's on my monitor, a separate screen. I do not see it. Yeah, go ahead, Taylor.
Hi there. I got a little bit lost with I think the part where it was joining the city tracks with track variables. Do we need a successful exercise 1 in order to do exercise 2?
We don't.
Okay.
Yeah,
I'll come back to this then. I just want to make sure because I got lost and wasn't able to get to the end.
Do you mind just elaborating so where do you get lost, I guess?
I tried running the join city tracks with track variables, and then I started getting an error in rename says can't rename columns that don't exist. Column estimate doesn't exist.
And column. Okay. So you might have, actually the error might start somewhere here if you have not, if it's related to rename. Make sure you have, so here I want to rename place name to city. And because there is a little space in this within between place and name, so I have to put a little backtick.
Oh yeah, the backticks.
Yeah, so make sure you have the backticks here, otherwise
yeah, I didn't change anything.
Okay, so all right, if it's something more complicated, let's leave it to the probably back, but yeah, you don't need it for the next exercise.
Okay, all right, thank you.
All right, no problem. Okay, so let's go ahead to exercise 2, create multiple variables to extract multiple variables to create local profile. So here you can see that I actually specify a variable list first. I tell R that I want population. This is median age, and then the population of non-Hispanic white, and then and this equal to this who knows what variable ID names. So I guess the first question is, how do you know what is what, right? So you have to go to the dictionary to look for these variables within the ACS data. And let's go to our training material. So I provided two different versions here. So in our part 1 Toolbox Tuesday 2 years ago, this useful 2022 Census VARS KK guide is made by the instructor back then. It's made by Kevin. So I think it's a pretty good place to start. What he did here is to curate a number about 120 something variables that are very commonly used in your analysis. So it has the description, it has the code. So this pretty much can help. This pretty much will allow you to do a lot of stuff, but of course, in practice, analysis often needs to be customized a little more. So if this curated version made by Kevin does not have everything you want, we can go. I made another version. So this is the ACS 2022 table shells selected variables. Oh, another thing is when I went through my slides, I mentioned that you can download the table shells from Census. The link is on the slides, but pretty much it will take you to a site like this, and you can download the detailed table shells for the ACS survey that you need. And 2022 is the most recent version. I downloaded that, and I actually make some changes here. So the downloaded raw version here is called all variables. That contains every table and every variable within this 2022 ACS data. And it will tell you whether it's available for both 1 year and 5 year ACS or just one of the data set. So as you can see, this is a lot of variables to go through, and if you are not familiar with the census data, this is a very overwhelming place to start. So I kind of create 4 different tabs to put in. Each tab contains a couple tables that are pretty commonly used within the topic. And the topic, it's a little loose here because there are obviously some variables can be placed under different topics. So I think a good way to start is to start with the curated version from Kevin, or you can start with the different tabs here. So for example, in demographics, I include this population, sex by age table, and the median age, total population, race, ethnicity, nativity, citizenship, etc. Try to keep it under 200. And if you just look at the name of the table, it will be more straightforward. And the other thing to pay attention is the universe for your variable. So the universe literally gives you the universe for which the variable is tabulated for. I think best, and this total, which is usually the first variable for this particular table, it should be the count of your universe unless otherwise specified. Best practice is especially when it comes to count variables like population, household, etc. Best practice is to always get your universe variable before you get other subpopulation or subgroup variable. Because I think the right way to calculate percentage, for example, well, this is a little too straightforward, but the right way to calculate percentage is always divide your subgroup over the universe. Use the universe variable as your denominator. I can elaborate it more actually. The other thing to pay attention is indentation among a table group. This is too long. Let's look at a little shorter one. Okay, this is a good example, the race table. So you can see that you have total, and then you have the first level of indentation, which give you these different races ranging from whites to Native Hawaiian and other Pacific Islanders. Actually range all the way to multi-races. And then under multi-races, you see like a second degree of indentation. So these are subgroups under 2 or more races. So these, if you add these together, it will equal to the total. And these two, if you add it up together, it will sum up to the total of multiracial. And yes, so indentation here. Let's see if there's a better example. Yeah, so here you can see for the place of birth table, it's even sliced into more groups. So there are subgroups under native, subgroups under foreign born, and then there are more subgroups under naturalized US citizens, more subgroups under not a citizen. So just pay attention to these indentation and make sure you are working with some parallel categories when you're calculating percentage or calculating the sum, etc. So let me adjust the windows. So now what we want to do is to use these information to create a variable list that we want to tabulate for city. Let's start from the top and start with some basics. Population, which is pretty much the total for this sex by age table. The unique ID gives you the code or ID for this variable. So I'm just gonna start making notes here, so it will be more straightforward later. So population, I get B01001_001. And let's continue. Let's say we want median age for the entire population. So that will be this, and we just name it MED_age. Med age equals this code in quotation marks. And later it will, let's see, we want race, ethnicity. We want non-Hispanic white. So we'll go to this ethnicity table and non-Hispanic white. So here's a good example. It's a subgroup. So you see population is segmented into non-Hispanic versus Hispanic or Latino. And then under non-Hispanic, you have these different races. And what we want is non-Hispanic white. So we'll typically just copy and paste it in your R code. And foreign, what I want is foreign born here. So this table, you can see foreign born is its own category, so that's great. So now we've gotten a couple variables in the demographic one. I want to check out this housing and household tab. So let's get the number of households. So in census term, household is occupied housing. So that, and one place to get it is from the tenure table. So here it will give you total occupied housing units, which substantively means total households. And we also want to get the number of renter households. And let's find an example from the economic tab. And of course, what's more popular than work from home these days? So we're gonna get get it from this means of transportation to work table. The total, pay attention here, is workers 16 years and over. So that's what I meant earlier. Always best practice is to get the universe variable, because when you calculate the percentage working from home, you want to calculate the percentage of workers that work from home instead of using the work from home workers count over your total population. So we get the number of workers. Here we have workers, and then the work from home category, it's all the way down here. So we get work from home variable here. Okay, so hopefully this gives you some idea of how to navigate around census data, or look into this giant dictionary to find census variables. And a lot of the time it does come with experience, because you want to know, because after having worked with it for a long time, you will know what certain variables are called. But if it's pretty new to you, I think this is a pretty good place to start. All right, so now back to R. We just created, using that dictionary, we created this variable list. And the next block of code, I hope it looks familiar here. We just make some minor change here using get ACS. So this time we want to create local profile for a city. So instead of track, we change this parameter into place, census term for local jurisdiction, and then variables, because we already specify variable list here, so we can just say that the variables will come from this variable list. And one more change I made is to set geometry as false, because I don't plan to map it. And sometimes with geometry, it may slow down your processing time. So that's why, based on your need, you can turn this off. And instead of, we already have ACS data, I want to create something, another thing. So it's ACS2. And you want to run this one first, because this one, you can see like a little path dependency here. You have to have variable list specified before you can run this. So let's go ahead and run these together. First, run var list, and it's created. It's not a data frame, it's just a list, and it will still show up in your environment. And now we can ask R to extract your data. Okay, that's pretty fast. So here you can see, again, you can see it's place level data, and extracted for the entire state of California. I'm gonna cue back that census geographic hierarchy graph, place nest within state, but not county, because some unincorporated areas actually cross boundary lines. Okay, so now let's take a look at this ACS data too. We just extracted from census. This time, because we extract multiple variables, this data is in long form, meaning that each row, so we have multiple variables and they all stack together for one city. So here you can see, let's go back to the city of Adelanto. The city of Adelanto here has 8 lines, because we extracted 8 variables. And we also, when we are specifying the variable list, we create this population variable. We kind of name these variables. So here it won't show up as B01 something, but it will actually show up as names. That is more helpful for you to navigate through this data. And similar as before, you have this estimate, this column called estimates, that give you the numeric value for your variable, and then margin of error. Okay, but this long format of data is not very friendly when it comes to data processing. So what we want to do here is to convert your data from long form to wide form. I'm going to run this line first to show you what wide form look like, and then I'll come back to it. So we run it. And now, again, ACS2, the results will be stored in ACS2, so I just overwrite it. So now it looks very different, right? Now each role is it's a local jurisdiction, either an incorporated area or a city, and you have all these variables lined up for this city. I think it's a lot more straightforward this way, and it's also easier when you want to create new variables. So for example, if we want to calculate the percentage of workers working from home, it will be the variable work from home divided by variable workers. And you can't really do it with the long form data. So that's why we go through the step to convert data from long form to wide form. The function we use is called pivot underscore wider. So we're gonna convert this original ACS data to long form and the ID columns. So each row will be identified by its GeoID and name. And the names of the variable, the new variable, will come from the original variable. And the values will come from the estimate variable. Let me just try that. Let me just run this again and show you what exactly it's doing. So I rerun this. And please don't crash. Okay. yes. So I just call this again from using the get ACS function. So what we do is to tell R, we're gonna pivot this data from long form to wide form. Each row will be identified by the GeoID and name, and then you will have the variable stack as column. The name of each column will come from this variable column, the third column, and the values for the newly created cells will come from this estimate. And in this case, we get rid of margin of error just for today's exercise. And this next step, it's our data wrangling process again. We did something similar up there. So we have the pipe operator, and then next thing we want to filter. This time, in addition to the city of Santa Ana. So here, let me pivot it first. So this time, in addition to the city of Santa Ana, somewhere here, it will have the name equals Santa Ana. I also want two other adjacent cities. So I included Tustin and the city of Orange. This is OR logic, a logical operator in R. So you filter for these three cities and use your mutate function to create a couple new variables. So very typically we are interested in percentage. So we want to calculate the share of non-Hispanic white. So simply, it's just non-Hispanic white over population. Here, I multiply it by 100 to automatically account for the unit. And then I also want to calculate the percentage of foreign-born, and then calculate the percentage of renters, and then so when you calculate the percentage of renters, you divide it by household. So again, best practice, always get your universe variable. And lastly, you calculate the share of work from home workers. So it will be workers that work from home divided by total workers. I also created a new variable to specify the data. The time period for this data is from the 2018 to 2022 5-year ACS, and that's just for my record. The last step here, I want to streamline the data set, so I keep the variables that I want. What I want here is the name of the city, and then these population, households, workers, and all the variables that start with the name PCT. That's how I created these variables. So I want to include all these percentage variables that I created, as well as this year variable I just created here. So, run. Let's see, how does it look like? Is it, it's city data. All right, and I store the results. As you can tell here, city data 2. So this is what you get. I think it's actually pretty interesting. You can see that the city of Santa Ana is much larger in population size, but the share of non-Hispanic white is way lower in the city of Santa Ana compared to these two other adjacent cities. And meanwhile, the percentage of foreign-born population is over 40% in Santa Ana, and this is also remarkably higher than the foreign-born share in the city of Orange and Tustin, and relatively low percentage of work-from-home share. We are almost there. So step 4, we use this write CSV function to export the data into a basic CSV file. So here you can look at my output. This is what I exported. And so if you export it in Excel, I think that just gives you a little more flexibility and also simpler if you want to do some extra formatting that's too cumbersome to do it in R. And I want to spend the last 2 minutes to race through this optional portion because I think it's very interesting. And I can race it through because this is pretty much a copy of the slide of the functions up top. So what I want to do here is just to repeat step 1 to step 3, but instead of drawing data from the 2022 ACS, I want to draw data from 5 years ago, which is the 2017 5-year ACS data. And we have ACS data 2, so we're going to create a separate data frame called ACS data 3. So it's a simple change in parameter here. Instead of 2022, it's 2017. And instead of ACS data 2, it's ACS data 3. So make sure if you are doing it yourself, make sure you change all the parameters that are needed to be changed here, but it's the same codes. You just literally change two or three names or items. So let's just run this whole chunk, and it's take city data 3. All right, city data 3 show up here. As you can see, similar, but instead of 2022, this is from 2017. And one last thing what I want to do is to combine these 2017 data and 2022 data together, so you can have a little historical trends to look at. So last thing I'll create is city data 4, which use rbind function to combine these two items together. And does it run? Yes, it ran. Okay, so you can see that I have all these variables tabulated for today and then also tabulated for 5 years ago. If you can actually sort the variables like you're in Excel. So if you just click this little arrow here, it automatically put these cities together. Let's just see, work from home, it increased dramatically in this 5-year time span, and we all pretty much know why. But yeah, it's a pretty universal pattern change here. And regarding Santa Ana City, which we've been looking into, another noticeable change is the decrease in the percentage foreign-born, which actually, even though it's still pretty high, but it dropped from 45% to 41%. So I think there's the last step is to export this in Excel, so you can do a little bit more formatting, table work there. And the last example, it's going to be a little take-home exercise. Again, if you have any issues setting up your packages or other things in R, you are welcome to reach out to me. And with the right setup, you should be able to run this advanced example too. But it pretty much just put 1 and 2 together. So it's not really advanced, just one more exercise. Okay, it's 2 minutes till 2:30. I'm happy to stay I'm happy to stay longer if you all have questions, and I hope this session is helpful to you. And I'm gonna give it back to Amanda.
Okay, great. Thank you so much. Edward, can you please bring the slide deck back up? Awesome. So here is some more information as well as Echo's email address if you wanted to follow up about any questions. And then finally, we ask, please take this quick 2-minute survey to tell us how we did to improve future Toolbox Tuesday surveys. We have the QR code here, and I posted the link in the chat. I believe we did have one question earlier from Peter that Echo, if you have a minute, he asked, is there a simple lookup or table of contents that indicates what ACS data fields are available at the tract and census group levels and at the 1-year and 5-year sources?
So in terms of looking up for data, I recommend you to start with the Excel spreadsheet. So the table shells put together by Census Bureau, and then we do a little more curation there. But pretty much the ACS 1-year and 5-year have almost the same sets of variables, only a couple variables that are not overlapping. The main issue here is with ACS 1-year, you can only do analysis for geographies that's at least 65,000 in population. So pretty much for smaller counties and then cities and census tracts, block groups, ACS 5-year is your way to go. But the variable sets, they are pretty much the same across these 2 data sets.
Okay, and did we have any other questions? We can both stay a couple of minutes in case there was anything else that anyone wanted to cover before we end the session for today. Okay, I'm not seeing anything. So again, thank you all so much for taking the time to join us today. We hope that this was very educational, and please take our survey and be sure to join us next month for our August Toolbox Tuesday. And thank you again, Echo. Thank you so much.
Thank you, Amanda.
All right, everyone have a great afternoon. Thank you.